convert to bits. Bits represent one of two values 0 or 1 and are joined together to form binary numbers. Initial permutation. The initial and final permutations are straight D boxes that are inverses of each other and hence are permutations. They have no cryptography significance in this. Expand right. It is the way through which we get 16 subkeys of 48 bits from the initial 64-bit key for each round of this. The generated keys will be used during the encryption of plaintext.
The XOR operation is employed in two locations within the DAS block encryption itself. First, XOR 48 bits per round on the input of S boxes. 48 bits from a subkey extracted from the 58 bits key, and 48 bits from expansion is output. The box's 6 bits input are formed by the 48-bit result. Second, XOR 32 bits every round on the output of S boxes. 32 bits from the former left half of the state and 32 bits created by the S boxes 84-bit outputs. The new right half of the state is formed by the 32-bit result. The substitute or substitutional boxes. The S boxes carry out the real mixing confusion. The real mixing is done by the S boxes. The DES algorithm employs 8 S boxes, each with a 6-bit input and 4-bit output. There are 8 S box tables in total. All 8 S boxes output are then merged into a 32-bit segment. Next, permute. A permutation box or a P box is a bit shuffling method that is used to permute or transpose bit across S box input while retaining diffusion. A 64-bit expansion P box that distribute the input S boxes to as many output S boxes as possible. The S boxes and P boxes are used in block cipher to make the relationship between the plain text and the ciphertext difficult to understand. P boxes are usually classified as compression, expansion, or straight based on whether the number of output bits is less than, greater than, or equal to number of input bits. Only straight P boxes can be inverted.
XOR left. Every move is right and positions. In case of sign to complement numbers, the sign bit is moved into the MBS position. It is the equivalent of dividing the number by 2n times. Rotate halves left 1. Each pair of blocks Cn and Dn is formed from the previous pair Cn1 and Dn1 respectively for n1, 2, 3 to 16 using the following schedule of Y left shifts. Move each bit one place to left except for the first bit, which cycled to end of the block. Extract bits by applying an end mask with every bit to 0 except those you want to extract, which you will set to 1. The reason is that 0 and x equals 0, but 1 and x is equal to x. Shift bits to position you need them to be. Clear the bits by applying an end mask with every bit set to 1, except to those you want to clear, which you will set to 0. The reason is the same as the above.